Hello. So, the greenhouse is a polytunnel. The door is a plastic sheet that zips upwards, and I'd like to be able to automate the opening of this when it's too hot, because I'm not here all the time to do it. And so I plan to put a mounting beam across here to mount the motor that's going to power the winch, and then this is going to be mounted against the frame like that. The frame is a metal hoop that is 2 meter diameter. So I'm going to make some brackets to fit there, and then use like a blind, a couple of loops of string or rope around the bottom of the door with a tube zip tied that can then be rolled upwards. So that's the theory. The first task was to design and print the brackets to attach the support beam. This was one of the first things I'd ever designed for the 3D printer, which I did long before I bought this printer. I'd actually just planned to use someone else's, but I kept thinking of ideas for things to print, so I finally committed to buying one. This is the Prusa i3 Mark III S, and so far it's been very reliable. I'm printing these brackets in PETG, which is quite strong as a construction material. See what this fits like. Not too far off. Could do with being trimmed down a tiny bit. Let's see if this fits. Yes! Pretty cool. The next part is to attach something to the bottom of the door to create the lifting mechanism for the blind. So I'm using a piece of UPVC pipe. It's a little bit too flimsy, I think, but I'm going to give it a try and see what it's like. Attach that with some zip ties and then loop some paracord under it to use as the winch, and then a couple of pulleys to see if I can get one on each side to go to a single motor. I've cut the pipe to length, so there's about 20 centimeters of overlap between the edge of the door and the end of the pipe, and that's so that when it's lowered down I could put a stake here to guide it into the position that it should be in, so it's not blowing open with the wind. I'm going to try and roll this door inwards for two reasons. One is it keeps the rolling mechanism on the inside and out of the rain, and also it stops rain collecting inside the door as it's rolled up. The door gets turned into a roller blind by looping some sort of twiny stuff underneath and up the other side. On the inside it looks like this. One guide wire up each side attached to a pulley. Pulley diverts it to the middle and then is attached to this 3D printed bevel gear, which has enough of a groove for both sides of the wire to winch round. And then the bevel gear attaches to a 12-volt motor. The other side of the gear attachment is underneath, and they don't clash. And this has bearings in it so that it's to minimize the resistance. And this is where it's controlled. It's powered by a 12-volt input from the mains, which have just run out of the window. We've got a voltage regulator to drop that to 9 volts to power the Arduino. This is Arduino Nano. LCD display and a couple of relays, so that when the temperature gets above 28.2, the door will open. When it drops below 19 in the evenings, it'll close. I missed the trigger temperature, so I pressed reset to demonstrate the mechanism working. Incidentally, the important thing with this setup is that you start the Arduino with the door in the down position because the code assumes door state 0 is down. This is the circuit diagram for the electronics in this project. Some notes on this. The DHT11 temperature and humidity sensor is represented here as a variable resistor just because the web-based program I used for the diagram didn't have the DHT11 as an optional component. The DHT11 module board has 3 connection pins, but I believe the pins can vary according to the manufacturer, so if you try to copy this, check which pin is which. The data pin connects to pin 2 of the Arduino. The relay modules I used have 3 input pins because the relays are mounted on boards with an indicator LED, but again the plus 5 volt and ground pins are obvious, and the 2 relays trigger pins are connected to pins 4 and 6 of the Arduino. The code is a bit of a mess because I'm not a coder at all and a total novice with Arduino. I couldn't find anything exactly like this project online, so I had to patch it together using bits of other projects and a bit of trial and error. Nevertheless, it works fine. If you're like me and not a coder, or if you're new to Arduino, the text after the double forward slashes is just annotation that doesn't interfere with the code, so it isn't needed at all.